Hi, I'm Mrs. KJ. I hope you're having a great day. I'm going to start out with some notes for Unit 1. So what I have here is, you notice that I made a new file for myself, and I just called it 1.01A Notes. And this CR is just like the technical name for the class, so you don't have to put that. It's just for me so I can stay organized. Anyways, what I did is I started with the equations table that I gave you to use on the checkpoint, because these are all things you're going to want to have. Then I put down our lesson number, 1.02, Behavior of Gases. And if you notice it's a little bigger just because I changed it to a heading, you don't have to do that either. But I figured this would be a good way to keep notes organized, because when you make something a heading, it puts it over here on the left column, so you can jump around your document pretty easy. All right, let's check this out. Anytime there's a diagram like this, I like to copy it and paste it into my notes. So you can use the snipping tool. If you're not sure how to use the snipping tool, please let me know. And I would just copy paste that right into my notes. And then check it out. Gas. All right, we're talking about gases, like the air, not gasoline. Gasoline is a liquid, even though we call it gas, which is silly. And that's why the rest of the world calls it petrol. Anyways, gases like the air, composed of atoms and or molecules. They are in motion. Well, that is why we have temperature differences and diffusion. Diffusion means going from areas where there's a lot to areas where there's a little. In other words, spreading out. Gases are composed of atoms and or molecules that take up space, and we call that volume. So volume is just how big something is three-dimensionally, how much space it takes up. Gases are composed of atoms and or molecules that have space between them, and that's what gives us pressure. Think about if you are on a bus and you're really close to someone, you feel a lot of pressure, right? Versus if you have lots of space to spread out. So that space that you have, that's going to dictate the pressure. And because gases have space around them, they can be compressed. They can be squeezed together. All right, so it says you can use a balloon to determine some of the properties of gases. At some point in your life, you have blown up and played with balloons. Balloons contain gases such as air, which is a mixture of gases, or helium. The gases inside exhibit certain behaviors that you can see or feel by handling the balloons. In this lesson, you will learn about the behaviors of gases by exploring the phenomenon of balloons. All right, you can use this stuff if you want to. Personally, I don't, so I'm going to kind of skip over it, but of course, do what's best for you. So then I'm going to hit the arrow, which is going to take us to the Explore section. As you read through, again, you can use these if you would like. We might come back to them, might not. What is a gas? Matter exists in several states: solid, liquid, gas, plasma. Like all matter, gases have mass, but they do not have a definite shape or volume. They will fill whatever container they are placed in and thus take the shape of that container. So here we can see the particles are going to spread out. Think about someone who takes balloons and turns them into balloon animals, right? The gas fills up the space, whether it's a long balloon, a round balloon, or a balloon that's turned into a puppy dog. Okay, so that's what it is saying. All right, so for your notes, let's see here. See if this magically works for me. It does. So instead of having this, I'm going to just put states of matter, because I want to have as few words in my notes as possible so that I can just scan them again later, but enough words that I know what I'm talking about. Okay. So, all right. So gases have mass. Mass is a lot like weight. It's technically different, but for this class, you can think of mass as weight. And it says they have no definite shape. So no definite shape is just a fancy way to say they spread out. And then we also want to say no definite volume. So because they're spreading out, they fill the container they are in. So think about this. If I have my glass of water here, there's my webcam. My water only goes up to here, right? I mean, obviously I can drink some water or add more, but my water is always at this amount. If it was a gas, the gas would spread up the whole container and actually fill up my room. That's why you can smell a candle across the room when it's burning, because those gas molecules are traveling. All right. Scientists know that a gas consists mostly of empty space interspersed with atoms or molecules. The atoms and molecules are in constant motion. They move rapidly, collide with each other, bounce off, and collide with the walls of containers. All right, so this is a huge thing in chemistry. All atoms and molecules are always moving. That is a huge idea. Next slide. A simple balloon can demonstrate much about gas behavior. So let's look at the picture first. One behavior of gases is that the volume is proportional to the amount of gas if temperature and pressure are constant. Eek. It's not that bad. It's just saying how much space a gas takes up depends on the temperature. Think about if you've ever had helium balloons. When you are outside in winter, the balloon gets smaller because it's cold. And when you bring it in the house, it pops back up to its full size. So temperature is going to affect how spread out the gases are, and pressure, right? We can squeeze things together. What happens when you blow into a balloon? You see that it expands to a certain size. But what determines that size? How big does the balloon get? What factors influence the size of a balloon, specifically the volume of the gas inside? These were the same types of questions asked by chemists in the 1600s and through the 1800s. Blow into a balloon again. What happens? Well, it gets bigger, right? In the first breath, you placed a fixed amount of air or air molecules into the balloon. In other words, you only have so much air in your lungs, right? And it all went into the balloon. In that second breath, you added more air molecules. What can you conclude about the volume of the balloon and the amount of air? If you said the volume gets larger as the amount of air inside increases, you are correct. Did conditions in your room change? Like, did it get colder or was there more air pressure? No. So there's really those three things that we need to know about as far as how gases act. And it's how much of the gas we have, the pressure, and the temperature. And that's going to tell us the volume. One behavior of gases that you can see is the volume of the balloon is proportional to the amount of gas in the balloon as long as you maintain constant pressure and temperature. All right, so the amount of gas in a balloon is proportional. In other words, is related to its volume. If you like the word proportional, go ahead and use it. Proportional just means it goes up by a certain amount. Like if I double something or triple it, that would be proportional. All right, let's look at the picture again. You can measure the force exerted per unit area inside a tire with a pressure gauge. In other words, if you look at your tires, if you actually look on them, it says PSI. That means pressure per square inch. So it's how much pressure is in your tire, whether your tire is inflated or whether your tire went flat. Changing the volume of a gas changes the pressure it exerts on the container. The carbon dioxide in a fire extinguisher loses pressure when the valve is released. So a fire extinguisher is a good example of how it's all contained, but then when you release the gas, it has more space and the pressure changes. Gases exert pressure. Take a balloon, place 1 or 2 breaths of air in it, and tie it off. Take your finger and press on one side of the balloon and let it go. What happens? You placed a dimple in the balloon and the original shape came back. Why? You placed a force on the air inside the balloon with your finger. When you let go, the air inside the balloon exerted an outward force that restored the balloon shape. So gases exert a force. All right, so that's kind of a main idea there, right? Gases exert a force. Specifically, the air molecules inside collide with the walls of the balloon and exert force. We call that force pressure. All right, so I got a vocab word. I'm going to write pressure equals, and I'm going to paste. The force applied to a unit area of a surface. Pressure is defined as force per unit area. The metric system unit of pressure is called the Pascal. All right, so SI just means metric. So again, we have a vocab word. We are going to put that in our notes. And delete all the extra junk it copied. And SI is System International, or in other words, international system. But here in the US, we call it the metrics system. And it's abbreviated as PA. It's named after French chemist and mathematician Blaise Pascal. Common pressures are measured in kilopascals. Okay, so that's one that we're going to see a lot. So 1 kilopascal equals 1,000 pascals. Besides observing pressure in balloons, you probably encounter pressure when you inflate other things such as bike tires, car tires, basketballs, or soccer balls. The Earth's atmosphere exerts pressure called barometric pressure. And I'm going to pause this video right here. You might have heard my timers. I got to teach another class, but I will continue the rest in another video.